currently that we were discussing the post regression, and we discuss the post regression in two types of setting. One is a low gradient setting, that is wave dominated low gradient setting, and the other is a fluvial dominated or delta dominated high gradient setting. These two settings we have actually discussed about the post regression. Now, whatever we have discussed about the post regression, that actually we discussed in the marine part, because we always talked about with you that the main sequence stratigraphic concept that basically was developed in the transition zone, where the continental and marine process needs to interact with one another, and depending on their interaction, we interpret the entire history of the sequence stratigraphy. If you go to the entire continental side, then the control of the sea level and all these things that goes. And if you go to the deep marine side, then the control of the continental process, that is the fluvial incision and all these things, that is not available. So the best possible where you get all the signatures that how the continental and marine process, they are alternating and responding to the relative sea level or base level change, that is the best area for us in the sequence stratigraphy perspective. This aspect I have discussed earlier also. Now, why I am again discussing it today, that to emphasize on you that what the post regression that I have discussed about the marine part, that how the shore phase that creates a basal surface of post regression, the regressive surface of marine erosion, and bounded between that and the correlative conformity. So all those that I have discussed on the what is actually happening in the immediate continental part. What is actually happening in the when there is a relative sea level fall? What will happen in the immediate continental part? As I discussed in the last class, that when there is a fall, when there is a base level fall, then what I said that the river system, they will actually try to equilibrate with the new base level, and by means of the erosion, incision, bypass, that is what we have talked about, isn't it? Isn't it?
Yes, sir.
Yeah. So that is the only thing that I have talked about. That when there is a base level fall, that there will be incision, bypass, or degradation in the fluvial system. That I have. Now I will discuss that this is again a overgeneralization. This is again a overgeneralization that all the fluvial system with the base level fall need not have to incise, need not have to degrade, need not have to bypass. And then when it will be incising, when it will be degrading, that is also again a specific, there is a specific reason. So now I will come how a fluvial system that will behave with the base level fall. In the marine part, we have already discussed. Now we are discussing the fluvial part. That how will the base level fall? So there are three. It is the fluvial response that we are talking about, and we will be talking about three different cases that how the fluvial system responding to base level fall. Number one. Please draw the diagram. There are 3 different cases. Please let me know after drawing the diagram. Is it done?
Yes, yes.
Okay. So actually we are now discussing 3 different cases. How really a fluvial system will behave when there is a base level. When there is a base level. Okay. Now first case where your coastline slope or alluvial valley slope it is less than the shelf slope. If this slope is less than this slope, then what will happen that any fall that will cause the incision and degradation. So this will cause incision, fluvial incision. So what I am saying that if I have this, so this is at time 1, time 2, time 3. So new this will come here and there will be a net fluvial, so net fluvial erosion. So if you have the shelves, the coastline or alluvial valley slope, this is lower than the shelf slope, then any fall, any base level fall that will lead to the incision by the fluvial system. Clear? Now, second case, when the coastline slope and shelf slope they are equal to one another. So, if the slope is same, then there is no question of incision, no question of aggradation. The fluvial system that will be adjusting by its own sinuosity, by its own roughness, by its own bed load pattern, and it will be bypassing the sediment. It will not cause any incision, but it will bypass the sediment. It will neither aggregate nor incise, but it will bypass the sediment if it will be a coastline slope is equal to the shelf slope, and there the river system will adjust by its own change. That is the sinuosity, the roughness, the bed load, suspension load pattern, and by that it will cause the sediment to get bypassed into the from the coastal to the river marine system. Now I come to the third case, where the coastline or alluvial valley slope is steeper than the shelf slope. Steeper than the shelf slope. Then what will happen? The river system will try to aggregate. Rather than incise, it will aggregate. It will aggregate. It will aggregate. It will aggregate. So you see that in that case there will be an aggradation instead of incision by the fluvial system, and you get the development of the fluvial topset. Fluvial topset. Now, what is this K? What is this point K? K here refers to as nick point. K is K-N-I-C-K, nick point. What is nick point? Nick point is abrupt change in gradient, abrupt change in gradient in the river system, abrupt change in gradient in the river system. That is what is a nick point. Now, what is happening in this case and in this case? The nick point that will be shifting landward. The nick point will be shifting landward, either by the onlap or by the incision and degradation. So, nick point will be shifting landward. Okay, is it clear? I am discussing three different cases that with the base level fall, how a river system that will be responding to the base level fall, and depending on the valley slope and the shelf slope. So if the valley slope is steeper, if the valley slope is gentler, if the valley slope is same with the shelf slope, there are three kinds of behavior of the river system. In one case, it will be incising. In one case, it will be aggrading. In one case, it will be bypassing. Is it clear?
Yes, sir.
Okay. Okay. Now, once I discuss this thing, then we will now come on to sequence stratigraphic surface. We have already discussed the system trap, and now we will come to sequence stratigraphic surface. Sequence stratigraphic surface. Sequence stratigraphic surface, and their importance with respect to the system trap, with respect to the parasequence, with respect to the different trends in the shoreline movement, that we will be discussing most of it. So we start with a very general picture, and then we will go into the complications. So first, I draw a very general curve. So this is high, this is low. I am not saying, I am saying it is a relative sea level curve. I am calling it relative sea level curve. Okay. So in the relative sea level curve, what are the different surfaces that I mark? So I start with this point. I start with this point of the curve, and this is what I mark as BSFR, basal surface of post radiation. Okay. This is I mark at C6, correlative conform. This is I mark at MRS, maximum regressive surface. This is I mark at MFS. I mark at MFS. Okay? Fine? And then again I am reaching to the same point. Yes. Now, when you call it CC, you are actually combining it with subaerial unconformity and RSA. Combining it with all RS. SU and RS. Okay. Now, these different surfaces, they are actually defined some based on transgression regression. So some of the surfaces, suppose MRS, MFS, these are related to maximum regression, maximum flooding. So they are related to the TR curve, transgression regression curve. Okay, so they have a connotation. Now you are actually marking this MRS, maximum regressive surface, maximum flooding surface. So the term actually indicates they are related to the regression, transgression. So that is regression and transgression related to the movement of the shoreline. So movement of the shoreline, and it is connected. So R, BSFR, SU, RSNE, they are related to, yes, they are related to transgression regression, but the terms are not related to the transgression regression. The terms are related to the migration of the shore phase migrate canal. So that is related to the phases belt migration. You see, mixing of the terms. You see, mixing of the terms. Some terms here, they are related to the movement of the shoreline. Some terms here, they are related to the migration of the phases belt, basinward, or so. When people are coining this term, some people coin this term, another people coin this term. It is not that the single group of people they coined all the term. So different people, they actually propose this different term under different basis. Some are based on the TR cycle, some are based on the genetic stratigraphic unit, some are based on the depositional sequence. Now what I will do, I will tell you what is the difference between a TR cycle, a depositional sequence, and a genetic stratigraphic sequence. What does it mean, and how these surfaces, they are related to different concepts which are assimilated into the sequence stratigraphic concept. Assimilated in the sequence stratigraphic concept. May I erase this? May I erase this? Hello?
Yes, yes.
Okay. Please draw it. If you have any problem anywhere, please ask me in understanding. Reading the thing. Because this is a very important figure which will summarize whatever you are talking about. I will post that in the sequence static level group also. Please let me know when your is complete. हो गया? Is it done? Hello? Hello, is it done?
Yes, sir. Yes, sir.
Okay. So what actually is shown in this? There are actually I have written PR cycle, genetic stratigraphic unit, and depositional sequence. How the three things? These are three different concepts that has been clubbed in the entire sequence stratigraphy. Because different people they have taken the different surfaces for subdividing the stratigraphic succession. Okay. Now, suppose when you think about that, I am dividing it from MFS to MFS. Now, MFS to MFS, this seismic stratigrapher, they actually took this initially that to subdivide the stratigraphic succession, and they subdivided based on the MFS. Why? Because the MFS is the most areally extensive strata in the subsurface and easiest to pick up in a seismic transit. Whenever you do the seismic imaging of the subsurface, the MFS being the most areally extensive surface and most continuous surface, it is easiest to pick up. So say they subdivided and they made it the genetic stratigraphic sequence. Then afterwards, when the Exxon group came and they actually proposed that the subdivision will be based on unconformity. So the flooding surface gone. So the subdivision will be based on unconformity. Now the question is that how the unconformity will be picked up, because unconformity is that where there is a depositional gap and there is a erosion. So if there is a depositional gap and a erosion, then how I expect a product out of that? So when you talk about the unconformity and it is a depositional gap and a erosion, then it is no question that I will get a product. So what I will pick up correlatable to that event. So correlatable to that event is correlative conformity. So correlative conformity here is actually denoting the unconformity, because that unconformity is a diachronous surface. It starts falling and goes on falling, and then the top of that fall, the last fall event, that is correlatable to the correlative conformity. I will come to when I will discuss the correlative conformity. I will discuss that. What actually is correlative conformity? How I pick it up in the stratigraphic succession. Now, so then they subdivided the succession based on correlative conformity, but in their back of the mind, that what is working is subaerial unconformity. So whenever I am subdividing the succession based on the correlative conformity, I should keep in my mind I actually subdividing it based on the subaerial unconformity, because that is correlatable to the correlative conformity, and that is proposed by the Exxon group. So the thrust totally shifted from the maximum flooding to the unconformity. So seismic stratigrapher initially proposed it based on maximum flooding because it was easiest for them to pick up from the subsurface seismic image. Then genetically, the Exxon group thought, no, the subaerial unconformity is the most genetically important surface that should subdivide the depositional sequence. Because the maximum flooding may or may not happen in a basin, but if there is a fall, there will be always a subaerial unconformity that will be formed. So they subdivided that. And the PR cycle, that is completely different, because I have drawn two different. So one is the base level curve, another is the transgression regression curve. You see, there is an offset between the two curves. The two curves are actually not matching. there is an offset between these two curves, and this offset between these two curves that basically is giving rise to different sequence stratigraphic surface. Am I clear? The offset between the two curves, because I have a transgression. It is not that immediately the base level will be changing along with transgression. There will always be a time lag. There will always be a time lag between a transgression and the adjustment of the base level with the transgression. So the base level curve will always be a time lag from the transgression regression curve. So the shoreline movement curve, that basically is talking about the transgression regression curve, but the base level curve is not exactly a mimic of the transgression regression. It will always have a time lag, and there will be a phase lag between the transgression regression curve and the base level curve. This phase lag will be leading to the generation of the different sequence stratigraphic surface. Am I clear?
Yes, sir.
Yeah. Yeah. And this, so then the most important surface what they picked up for the transgression regression curve is the MRS, maximum regressive surface. As I talked earlier also, the MRS, MFS, these are basically depending on the transgression regression. So the MRS to MRS, that is what is the TR cycle that they talk about, the TR cycle. So some people, they rely more on the TR cycle, some people rely on the particularly the seismic stratigraphers, they relied on the genetic stratigraphic cycle, and the exon group sequence stratigraphers, they relied on the depositional sequence. But finally, when I make a sequence stratigraphic perspective, then all the surfaces, they come sequentially like this. If there is a very predictable change, that the sea level change, the sediment supply, everything is in equilibrium and they are governing very systematically. Very systematically. So all the factors that is in tandem, if I see that they are in tandem, then you get this kind of a situation that you have the different kind of surfaces that will be developed. Otherwise, sometimes what happens that the PST that is missing. So when the PST will be missing, then MRS and MFS, these two will be clubbed. We'll discuss what will happen if these two club. If PST is missing, that the translation is I am not getting. Or I may have that the LST is missing. That means after post regression, the sea level started rising at a very fast rate. There was no slow rate of rise initially, because the rise is related to a tectonic episode, and the tectonically immediately there is a subsidence and that is an immediate rise. So there is no LST. So the CC and MRS, these two will be clubbing. So all these things that will be happening because everything cannot go in the predictable way. But if I consider that it is a very predictable and everything is going in tandem in a very, very predictable manner, then you get this kind of a situation. Okay. Now here you are getting to a non-marine system. Non-marine system. Now in the non-marine system, what you will get? You will get a HST, but the entire from PSFR to what they call CC. This entire thing, that is a total subaerial unconformity. There is a total RST. That means the total thing that is a subaerial unconformity. Again, you have a LST, TST, and then there is subaerial unconformity. So in case of the non-marine, you are basically getting a TST, a RST. From HST to LST, including this, everything is coming in the regressive system. So instead of LST, instead of HST, there we talk about the RST and TST. RST and TST. So the RST is that when you have all the signals of regression, and the TST is that when you are we will discuss separately the non-marine sequence stratigraphy, how it is governed, and what are the signals that talk about the RST and the TST. That we will separately discuss, but just to compare with this, I am putting there so that when afterwards I will be discussing the non-marine sequence stratigraphy, it should be in your mind. Okay? we discuss these surfaces. The character of these surfaces, how these surfaces are identified, how these surfaces are characterized. So these surfaces we will be discussing now. Now, if you see that in the generally in terms of the seismic stratigraphy, because I will come to in detailed description of the different surfaces. The pipe surface that was taken care of in the sequence stratigraphic interpretation. 5 different types of surfaces. What are those surfaces? That if I take it in terms of the seismic stratigraphy and the statal relations. Truncation, top lap, on lap, down lap, and off lap. This 1, 2, 3, 4, 5. This 5 surface, down lap surface, off lap surface, on lap surface, top lap surface, and truncation. These 5 surfaces that in the seismic stratigraphy term, they are tied up with the sequence stratigraphy. What is the meaning of these 5 surfaces? Now, truncation. Truncation means that any underlying strata that will be truncated against this surface, and which is absolutely the surface which indicate you either erosion, non-deposition, or bypass. Erosion, non-deposition, bypass. Fine. Erosion, non-deposition. Now, if I come to the on lap. On lap is always related to a transgression. Always related to a transgression. Or increase in accommodation. Whereas off lap is always regression or decrease in accommodation. Decrease in accommodation. But when you come to down lap can happen both in transgression as well as regression. Down lap can happen both in transgression and regression. So down lap is a non-comital surface. Whenever I get a on lap, I can interpret that the relative increase in accommodation is taking place. And there is a transgression. I get an off lap, I can always say there is a regression and the net decrease in accommodation taking place. But I cannot say by a down lap that relative rise or relative fall in accommodation is taking place unless I get other criteria to supplement my conclusion. Supplement. So it can happen either in transgression or regression. You have down lap associated with transgressive strata. I have drawn that, and I have drawn in down lap along with the regressive strata. In both the cases, I have drawn the down. Now, what about top lap? What about top lap? इसको कहते हैं किसको? This is top lap. This is progradation. And you have, so suppose the surface is like this. So this is down lap. Is it clear? That is top lap. Now, when top lap will form? Actually, when this top lap is also defined by the seismic stratigraph. When they identify it as a top lap, when this strata, the thickness of the strata is below the seismic resolution, that what is normal seismic resolution is about 10 meter. Normal seismic 3D seismic, it cannot resolve anything less than 10 meter in thickness. Am I clear? So if something you have a strata which is less than the seismic resolution, then you consider that there is no net aggradation, and it is a surface against which the underlying strata they are truncated. So what the people believe that this is a steady state condition. The steady state condition. What is steady state condition? That in case of a normal regression, if the rate of sea level rise is exactly balanced by the sediment supply, neither sediment supply is more than the rate of sea level rise, nor it is less than the rate of sea level rise. Both are very, very delicately balanced, which can happen for a very short period of time. In normal regression. And in that case, what will happen? That the entire shallow marine strata that will be bypassed, and the sediment will be deposited in the frontal part in terms of progradation. But there is no aggradation because the wave regime with the relative sea level rise, that is exactly balancing the sediment supply. Am I clear? Is it getting clear to you?
Also, can you explain that part why it is progradation, not aggradation?
Yeah, absolutely. When I say it is aggradation, when I have this aggradation. What is progradation? Progradation is this. Prograde and aggrade. Now, question is that when this aggradation is so low that it is below the seismic resolution level, then I cannot identify that aggradation at all because it is below the seismic resolution level. And I said the normal 3D seismic resolution level is 10 meter. So 10 meter, below 10 meter, anything seismic cannot resolve. So they are now working to resolve more lesser thickness strata. That is a different story. We are not going into that. But normally, no seismic, it cannot be resolved. Okay. In that, then the question is that why it is happening and when it will happen like this. That it is not aggrading, but it is prograding. It can happen in case of normal regression. For a very short period of time. Because it requires a very delicate condition to prevail. What is the delicate condition? That sediment supply exactly balances the wave energy regime of rising accommodation. Normal regression is the rising accommodation at a very slow rate. And there the wave regime, when it exactly balances the sediment supply, So it will not allow any sediment to settle here. It will bypass all the sediment and deposit in the deeper part of the basin. And in that case, it appears to me that it is like a single surface against which the strata are truncating. But then it requires a very delicate condition, which in nature is very difficult to achieve, and even if it achieves, it will achieve for a very short time. There will be always a variation. Either the wave energy will increase or sediment supply will increase. But both will balance one another. That is a very, very delicate condition. And that delicate condition can only happen for a short period of time. And at that time, the top lap can generate. So that's why the top laps are always referred to in literature. You will see apparent top lap. Apparent top. टॉप लैप के साथ ऑलवेज एक टर्म apparent जुड़ा रहता है इन द लिटरेचर. ऑलवेज इन द लिटरेचर ये टर्म apparent इसलिए जोड़ा जाता है that it is actually a surface which is a surface of perception. Am I clear?
Yes, sir. And so this condition we expect only during normal regression.
Normal regression, and otherwise और बाकी कोई भी system track में it is impossible to achieve. This condition is not possible to achieve in any other transmissive system, any other system. Okay, fine. Now, if you see that this is so a truncation, it definitely indicates an unconformity. It indicates the erosion non-deposition, your on-lap, off-lap. That is a sure indicator of a translation or a regression. Down-lap is a non-comical. It can be related to translation, can be related to regression, and top-lap. It can generate for a short period of time with normal regression, with bypass of the sediment. Now, we come on to then discuss the different sequence stratigraphic surveys. First, we discuss the subaerial unconformity. Now, subaerial unconformity, it basically is. So we have already discussed how the subaerial unconformity, and it is a type 1 unconformity. A subaerial unconformity is a type 1 unconformity. And how it will be characterized? It will be characterized by erosion, incision, degradation, and pedogenesis. These are all characters of subaerial. It is a diaphanous surface. It is a diaphanous surface. And it starts with the subaerial unconformity. It forms above high-stand normal regression and it will be topped by low-stand normal regression. Am I clear? So if you see, so this is where the subaerial unconformity starts forming. It goes on forming up to this. So the entire period is the period of subaerial unconformity. What is underlying it? Underlying it is the high-stand normal regression. And what is overlying is the LST As a definition. As a definition. Okay. So if I have a product that is made up of subaerial unconfirmed, if I have a product that is made up of subaerial unconfirmed, then I can say that that is the product of the unconfirmed period of the entire period of all. It is a product. But if it is actually a product of erosion, incision, and all this, I may not get any product. Am I clear what I am saying?
So please repeat.
I am saying that there is HST normal regression. Above that, there is a base level fall and the subaerial formation. And after that, you have a elastic normal regression. So, what is subaerial? So, it is resting above a normal regression product. Ideally, I am saying ideally. Okay, ideally. सब कुछ सेम है, उसमें कोई प्रॉब्लम नहीं है, कहीं पर कुछ गलत नहीं हो रहा है, तो it is a equilibrium system में I will have the unconformity that is forming above a HST error and it is overlain by the LST. Now, what is an unconformity? If I say the unconformity is a base level fall, it is a pluvial erosion, pluvial incision, bypass. So, all these that there is a erosion and pluvial. So, there can be a case, hypothetically, you just try to imagine that everything getting eroded. Everything getting eroded. So, nothing will left for the unconformity. Nothing will left for the unconformity. In the entire period, everything is gone. And where it will go? It will go to the deeper part of the basin. Fine? In that case, how I will identify the unconformity? This is number one. And number two, if everything is not gone, then what will be the product of a unconformity? There are two cases. Am I clear? Are you?
Yes, sir.
Yeah. So, what will be the product of a unconformity? So, that is a actually sequence stratigraphy in a large aspect. It is a hypothetical, and from hypothesis the theory came. If you have to think, and from your think tank, from your brain, the ideas come, and that idea has been translated into the concept of the sequence stratigraphy, and that ideas goes on evolving in human brain, and that idea is still growing. Still, many new things are coming. It is not that the concept is totally established now. Even now, the papers are coming, new concepts are coming. There are more intricacies in the system that people are thinking. People are thinking, ये होना चाहिए, ये ऐसा होता है तो ये होना चाहिए. If it happens like that, then what will be the product of that? Do I really get that product in the rock succession? Then people go and try to see that kind of product is really available in the rock succession. Then match the observation and the thinking process. This is how sequence stratigraphy evolved. Sequence stratigraphy didn't evolve out of an experiment. Sequence stratigraphy didn't evolve by seeing only the rock succession. Sequence stratigraphy evolved out of brain. And sequence stratigraphy, actually the exercise of brain and rock. So brain is thinking something and trying to see that in rock. And if it matches with the thinking, they are saying it is this surface. If it not matches, then they try to evolve in brain that what exactly I am going wrong and how the nature is behaving. Am I really understanding how the nature is behaving? Now, In terms of hypothesis, I am saying a subaerial unconformity, it may not leave any record or it may leave a record. If it doesn't leave a record, then how I identify it? If it leaves a record, then what kind of record it will be? This is my aim. Now, suppose there is a shoal line. And there is a river system which is merging this shoal line. And they are in equilibrium. They are in equilibrium. So this is sea level. This is the alluvial line. They are in equilibrium. Now the sea level starts falling. But the initial fall is at a low rate. Initial fall is at a low rate. So what the rivers, as I said, that the rise and fall and the movement of the shoal line, that is related to translation and regression. Now, once you do the translation regression, you move the shoal line. River will take time to respond to this change. River immediately cannot change. How? When there is and that is related to the base level change. And that change of the river and its response is related to the base level change. That graph I have already drawn. The translation regression graph and the base level. Now I am process-wise I am discussing. Now initially there is a low rate. So in the low rate, what river will try? And when there is a very low rate of sea level fall, then river will try to adjust itself by changing its sinuosity, roughness. River will try to change. So a meandering river, it will become a little braided character. And the river will try to adjust itself according to the situation. But when the sea level, it becomes the fall becomes fast and there is a significant fall. This adjustment of the river system will not do. So then what will river try to do? Then river try to incise and it will incise to a new equilibrium total. Incise to a new equilibrium. And in the process, it will be incising onto shallow marine and shelf system. Shallow marine and shelf system. They will be incising. Think of last glacial maxima. Last glacial maxima, the sea level has fallen 100 meters. So if you have a 100-meter fall, what is the depth of the shelf? Depth of the shelf is 200 meters. The maximum depth of the shelf. And you get a sea level fall 100 to 120 meters sea level fall. So a large part of the shelf that got exposed. A large part of the shelf got exposed. And if that shelf gets exposed and river that encroaches onto the shelf, incising on the shelf, that kind of incision we refer to as incise valley. We call them incise valley. How incise valleys form and how really what is the field of incise valley we will discuss separately. I am not going to the full-scale discussion of incise valley today. We may discuss it in the next class. And that incision of valley onto the shell, that is what is called incise valley. And that the incise valley that basically preserves the product of the river system. Preserves the product of the river system. Okay. Another thing that we get, that as the surface gets exposed, and this is exposed surface and above which the river is coming, so this surface is normally creates a firm ground, and there are different kinds of trace fossil.
So the exposed shelf will show these.
Yeah, exactly. Exposed shell, there you may get two things, because the river will follow its own course, because the entire shelf is exposed. Not that every part of the shelf river can go. River is follow its own course. It will inside, but what will happen? The other portion of the shelf which is getting exposed, that will be basically either go for pedogenesis, soil formation, that is the interflume area. So there may be channels, and the interflume area we may get the pedogenesis or the soil formation, or there may be bypass, or you may get the firm ground formation where you get the trace fossils such as trypanite, teredolite, scolithos, trypanite, teredolite. These are the farm ground and the trace fossils which are also. So what I am saying is that suppose that area where I do not get a river product. So what is happening there? That the high stand shell, normal regressive shell, high stand, that will be overlaid directly by the low stand product, which may in between river I need.
Yes, sir. Yes, sir.
And how I then identify the type 1 unconformity there? I identify by the pedogenesis, I identify by the farm ground formation, I identify by the presence of different kind of trace fossils. These are my criteria for that part where the river system I am not getting directly overlying. Where the river system is coming, that much I am getting the incision and all this. What about where I do not get the incision? Okay.
Yes, sir.
Okay. And the entire unconformity, as I discussed, it is a diachronous surface. And the diachronous surface means that the river system that will be continuously with time, it will go on. Now, this is actually you call the subaerial unconformity. I am talking about the subaerial unconformity. I think the next topic, if I start today, because once the subaerial unconformity is gone, then what I will be discussing, because one by one I will be discussing. Next, I will be discussing the BSFR RSME, which are actually related to the subaerial unconformity of it also. So the BSFR and RSME, they are also related to subaerial unconformity, but that is happening in the marine part. That is happening in the marine part. So I think that the BSFR and RSME and this rather than today, I will discuss in the next class. The reason being that requires a time, and I don't want to stop that in between. I don't want to stop that in between. Okay?
Okay, sir.
Yes.
So if there is any problem in today's discussion, you can talk with me. if you have any problem, somebody sent me a WhatsApp that whether I have the Catania book. Yes, I have a Catania book, but that is also a Xerox. It is not the original book, and the condition of the book is very, very bad. Some of the pages are coming out, so it is difficult to Xerox from it. The library is issuing book. There is sequence stratigraphy book in the library. সুজয় আমি ক্লাসে আছি একটু পরে কল করছি So library has a book, and that book is you can issue that book and get it xeroxed. Or otherwise, the Aditya send you the soft copy. You can take a print out and buy it. I do not know who has sent me that WhatsApp. Okay, hello.
Yes, sir.
Okay, so let us call it a day. Thank you.
Yes. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.